Hello, can you hear me? Hello,
Hello.
yeah, you can hear me, right?
Yes.
Okay. At the end of the last class, I had shared some problems.
Oh, I thought we were doing AMC this class, so I did an AMC.
Okay. Uh, we are going to continue doing number theory and finish the topic. So
Oh, okay. All right.
we had seen a couple of problems, and I think I gave a couple of problems at the end of the last class. What was the question?
Yeah. Uh the question was oh yeah, here. A six-digit palindrome is chosen at random. What is the probability? Oh, a six-digit palindrome n is chosen at random. What's the probability that n over 11 is also a palindrome?
Right. So let's try that.
Okay.
We have n is a six-digit palindrome, and we have to also ensure that n by 11 is a palindrome. So n by 11, if you think about it, would be having, could
5.
have 4 or 5 digits.
Yeah.
It is possible to have a 4 digit number multiplied by 11 and get 6 instead of 5 digits.
Right. Yeah.
4 or 5 digits. So
Mm-hmm.
those are two separate cases, and you need to make it a palindrome also.
Yeah.
So you can work in case one where n by 11 is 4 digit. So in that case, it will look like A, B, B, A.
Yeah.
This is a 4 digit palindrome, and you need to multiply by 11 and get a 6 digit palindrome. So multiplying by 11 will look like this, and you need to add it, and it should add up to become 6 digit. So obviously that cannot happen if B plus A is less than 9, right?
Yeah. Right.
B plus A cannot be equal to 9 also. Like, 1 second, let me think.
Because it has to like carry over.
If there are no carryovers, it will be A plus B, 2B, A plus B, and A. But then
Yeah.
we get only 5 digits. So A plus B should have a carryover. Um, and if you think about it, if only A plus B had a carryover, then you would still be with 5 digits because there's a carryover 1 from here.
Oh, right. Yeah.
You'll end up with a A plus 1 digit here. So that means this A, it's still going to end up with a 5 digit. So you have to make sure that that also carries over 1, right?
Right.
So that means the A must be 9. So that even if a 1 gets from A plus B, you get a 1, that adds to the 9 and becomes a 10 and becomes a 6 digit.
Yeah.
So basically, A must be 9 and we carry over 1 from A plus B.
Right.
So then, however, there is a problem here because now, if you notice that even if there is a carryover from A plus 1, let's say the carryover was 1 and 9 was A, then you get a 0 here and a 1 here, right?
Right. Yeah.
Once it was 9 and 1 came, then it became 0 and a 1. But the problem is that the first digit is still A, which is 9, last
Yeah.
digit. So this doesn't become a palindrome.
Yes.
Basically, there is no chance that this can have a palindrome because if A was 8, then there is no carryover and it remains 5 digits, right?
Yeah.
But if A is 9 and adds a 1 from A plus B, it becomes a 10 and becomes 0 and 1, and then it stops being a palindrome because the first digit is still 9.
Right.
So basically, we have discovered that if it's a 4 digit thing, you cannot get a 6 digit palindrome. You can get a 6 digit number,
Yeah.
but it will not be a palindrome because the first digit here is still A and this digit has changed, right?
Right. Yeah.
So now we'll look at case 2, where n by 11 is a 5 digit palindrome. that may still be possible. So you have A, B, C, B, A. ABCBA is a 5-digit palindrome, and we have to make sure that when you multiply it by 11, it still becomes a palindrome. Right?
Yeah.
So the digits that come are A, B plus A, C plus B, B plus C, A plus B, and A. And you can see that automatically this is coming as a palindrome as long as there are no carryovers.
Yes.
Do you understand what I'm saying?
Yes, I understand.
So if we have no carryovers, then automatically it's a 6-digit palindrome. So now we don't want any carryovers. So now you just have to count how many possibilities are there, right?
Yeah.
The total number of cases where you can make numbers like this, where you can make a number ABCBA, it will ensure that the 6-digit number is also a palindrome, as long as there
Yes.
are no carryovers.
Right.
So obviously, the total number of numbers you can make is easy to count. We have to ensure no carryovers for it to be palindrome and satisfying every condition.
Yeah.
Total number of such 5-digit numbers is not a problem. You have to, you can do this in 9 ways, A, and
Hmm.
B can be taken in 10 ways, and C can be also taken in 10 ways, and after that it is fixed.
Yeah.
900 ways to make palindromes like this, right?
Right.
But now we have to count the smaller set of numbers which are possible in which we make palindromes such that when you multiply this also, there is no carryover basically.
Yes.
If you know how to do that counting, then you can find the probability. Do you understand?
Wouldn't you just say like A plus B and B plus C can't be like greater than 9?
Yeah, so that only you have to count now how many of these 900 are such that it can't be greater than 9 and all.
Oh, okay. Yeah.
There are 900 total number of such 5-digit palindromes. How many of them will satisfy such that A plus B, B plus C, all of them is inside the no carryover limit?
Five, 6, 7. 36, 49. I got 284.
How are you trying to count?
So I just said, let's say A is 8, then B and C could both be either 1 or 0. So that's four ways. Then A is 7, B or C could be 1,
You
2.
have to count. You have to count from all the cases of A. If suppose A is 1,
Mm-hmm.
it can go up to 8. So wait. So if A is 8, you're saying you have
Then
missed
B and
out on the 9 case. A can be 9 also.
oh yeah, because then all of them are just 0. Yeah.
Yeah, so you have to.
285.
No, that's still incorrect. You have missed something.
I did like, so you have the A is 9 1, and then I did if A is 8, then B or C could be either 0 or 1. So then that's four ways you can do it. And then if A was 7, B and C
If
could be
A is
0.
1, if A is 1 and B is 0, how many
Yeah.
possibilities of C are there?
Um, 10.
If A is 1 and B is 0, then there are actually 0 to 10, anything, right? 10 possibilities.
Yeah.
So, number of cases in that case is 10. Keep A fixed and change B to 1. Now, how many possibilities of C are there?
9.
0 to 8, right?
Yeah.
0 to 8 because you have to make sure that B plus C is less than equal to 9.
Right.
So there are 9 cases. So 9 cases here. Change B to 2, there will be 8 cases here, right?
Right.
Like this, you can keep going till B becomes what? B
Uh,
becomes 8,
yeah.
cannot be 9, right?
Right.
If B is 8, C can be what? 0 to 2. No, 0 to 1. Do you understand that there are only two possibilities for C?
Yeah.
So, two cases. This is the total number of cases that came when A was 1, right?
Yes.
So, you are getting 2 plus 3 plus so on till 10. So basically that is equal to 1 plus 2 plus till 10 minus 1, right?
Yes.
This is going to be n into n plus 1 by 2. So 10 into 11 by 2, 55 minus 1, which is 54 cases,
Right.
right?
Yeah.
Now we'll change A and we'll get A to be 2, correct?
Yes.
And if A is 2 and B is 0, how many cases for C are there? Still 10, I
Uh,
think.
yeah, still 10.
And if now you keep changing B, and now you will see that B can go up to what? B can go up to 7 now, right?
Right.
Right?
Yeah.
And C can in that case be up to 3. So it will be up to 3, right?
Right.
The same sequence of numbers, but 10 and 9, 8 up to 3. Correct?
Right.
So that would be 55 minus 2 minus 1. So 52.
Yeah.
Like this, you have to keep changing A to 3. Now you'll go up to only 6 and so on. Do you understand what I'm saying?
Right. I understand.
When you do it carefully and properly, you'll get 54 plus 52. This is for A is 1, A is 2, plus then you get the same pattern. But now, see, you subtracted 1 and 2. Then after that, you subtract 1 and 2 and 3 from the sum. How did we get 54? We got it by doing 1 plus 2 plus 10 minus 1, right?
Right.
That was in that first case. In the second case, you have to do 55 minus 1, then it was 55 minus 1 minus 2. Then it was
Right.
55 minus 1 minus 2 minus 3, and so on.
Yeah.
You will get 49 here. Then after that, you will get 45, then 40, then 34. These are the different cases for A. And
Right.
then 27, 19, and 10. 10 happens when A is, I think, 8 or something. 8 or 9. 9. When A is 9, for example, what can B be? B has to be 0.
Yeah.
But
And
you
then
said
C
only
can,
one case, but C can be anything from 0 to 9 now, right?
right. Yeah.
There are 10 cases for C. So this is for A is equal to 9. This is for A is equal to 8, and so on.
Right.
If you add up all of this, you will get 330, not 285.
Right.
Do you understand how we are counting?
Yes, I understand.
330 cases for 5-digit palindromes to multiply and give you 6-digit palindromes.
Yeah.
And there were total 900 ways to make 5-digit palindromes. So the required probability is 330 by 900,
Right.
which is 11 by 30. That will be your answer.
Yeah.
Is it clear?
Yes.
Okay. Uh, Fine. The next question is find the probability that a randomly selected divisor of 20 factorial is a multiple of 2000. Randomly selected divisor of 20 factorial is a multiple of 2000.
Okay.
In order to do the question, you need to be able to write the prime factorization of this.
Yeah, I got the prime factorization as 2 to the power 18 times 3 to the power 8 times 5 to the power 4 times 7 to the power 2 times 11 times 13 times 17 times 19. And then I got that the prime factorization of 2000 was was 2 to the power 4 times 5 to the power 3. So with that, you get 15 choices for what the exponent of 2 would be, because you can have any number from like 4 to 18. And then you'd have two choices for the 5's exponent, so like 3 or 4. So that's what you get for those. And then the others, you just do like, you just keep it the same, like the number of divisors, I guess. So you would just do like 15 times 2 times like 8 plus 1 times 2 plus 1 times 2 times 2 times 2 times 2. Because you add 1 to all the remaining exponents.
Now find the probability answer.
Yeah. I got 6 by 19.
Hmm. Yeah, that is correct. Next problem is given that this thing is equal to k into n factorial, where k and n are positive integers and n is as large as possible. What is k plus n? You should realize that obviously because of these multiple factorials, it's like actually a very big factorial here.
Yeah.
It is 6 factorial, which is 720 factorial technically.
Mm-hmm.
720 factorial divided by 3 factorial is equal to k into n factorial. You have to make n as big as possible, right?
Right.
Not so difficult. It's easy only. Write 720 factorial and write it as 720 into 719 factorial. You can immediately cancel the 3 factorial in the denominator now because that is 6, right?
Yeah.
What will happen here? 120
It's
into
times.
719 factorial.
So n is just 719.
You cannot have it higher than this. You need 720 multiplied by it.
Yeah.
So the highest possible n can be 719. If n is
Right.
719, k is 120, it's over.
Yeah.
Do you understand what we are doing?
Yes, I got it.
Okay. How many positive integers less than or equal to 240 can be expressed as the sum of distinct factorials. Distinct factorials. Here you should consider 0 factorial and 1 factorial to be distinct, even though the values are same. Basically, you have to say how many integers below 140 or equal to 240 can be written as a sum of factorials.
Oh, okay.
sum of different factorials. We'll consider for now that 0 factorial and 1 factorial are different. That is a special case. Every other factorial is anyway different from another number. So
Yeah. Would the answer be 64?
no, it is not. You can't see two ways of selecting either one of 0 or 1, or that's what you've done, right? Either keeping them or not keeping them.
Yeah.
You are saying 2 power 6, but that can't be done. There is a slight problem with that.
Mm.
The problem is that if it was just make up all the numbers which are possible to be written as sum of 3 factorial, 4 factorial, 5 factorial, there is no problem. Answer is 8. Because when you add any combination of these, they are giving a different number.
Yeah.
But that's not the case for the first three, because you can get less than 8 numbers from here.
Oh, right. Because 1 and 0 are the same.
So when you add any combination of these, the total possibilities are not 8.
Yeah.
So you have to be careful about those and calculate it appropriately. For these, there is no problem. There are 8 ways to either keep them or not keep them.
Yeah.
Or 8 sums from here to be found. 8 numbers you can make.
Yeah.
But actually, for these, you have only 5.
Right. Right. Yeah.
You can see it will be 1 to 4. All of them can be made, and also 0 when you don't keep anything.
Yeah.
And when you multiply this with this, you get 40 total ways. But one of the cases includes when you take nothing, which is 0.
Yeah.
So we'll subtract 1, you'll get 39 positive numbers because you
Right.
need positive integers. Why did we multiply the two cases?
Because it's like combination of both.
Ultimately, you would have done 2 power 6. You would have multiplied each case. But
Yeah.
there also we are doing multiplication principle. But it's not working like that because these are not giving 2 power 3. Instead of 8, they are giving only 5 numbers.
Yes.
So you're multiplying this with the 8 coming from here. You'll get 40, but that includes the case where everything is not there or 0 is coming as the sum. So we'll remove
Yeah.
that and our answer is 39.
Right.
Okay. The next one is let n be the number of consecutive zeros at the end of the product 1 factorial, 2 factorial, 3 factorial, and so on to 99 factorial and 100 factorial. This number, how many n is the number of zeros at the end of the product. Find the remainder when n is divided by 1000.
Wouldn't Oh wait, never mind, never mind. So I got that we can like count the number of five. So
Mhm.
so you get like 90 six fives like from 1 to 10, and then you get like for like a factor of 5, and then you get like 91 of them have like 10s, and then 86 have like 15s, and then so on and so on, and you get that like arithmetic sequence of like 96, 91, 86, and it's like subtracting 5 each time. So when you sum it up, you just keep on adding it, adding it and adding it. I got like 970, but then that's like not divisible by
Those are
1000.
those are 975s that you have gotten just powers of 5, but you have missed out on powers of extra powers of 5 that come when you have 25.
Oh, so then when you do for each one that has 25, that would be 76 more.
You have to be careful, but there are more 5s that come from 25. One more 5. When 25
Huh.
divides any of the factorials, you get an extra 5.
Yeah, so that's 76 extra fives. So then you get 970 plus 76, which is 1046.
How are you getting 76 extra 5s?
Because you have like you're saying like when you divide it by 25 you get that extra 5. So for each factorial it'll be 25 factorial to 100 factorial that's going to have that extra 25. So then there's 76 numbers between 25 and 100. So you get 76 extra fives.
How do you count the total number of 5s in a factorial? What do you do? Suppose you had 100 factorial. How do you count number of 5s?
mm, Prime factorization.
How do you find the value?
You'd like Well, there's one 5 and 5, then there's another 5 and 10, another 5 and 15, another 5 in.
You'll keep doing that. What's the method that we have discussed that gives you the answer? I had told you a formula or a summation.
Oh, I remember this. Oh, so it's like, okay, so it's just 100 to the power 5 and then 100 by 5 by 2 until it becomes greater than 100. So it's just these two. So then it's 20 plus 4.
If you want to find the number of 25s that are there in n factorial, you have to do the same thing. N factorial by 25 plus basically you want to find how many 25s are there in if you want to find how many 25s are there in n factorial, you have to do it for you can do summation of n goes from 1 to 100 n by 25 And this will count how many 25s are there in n factorial.
Yeah.
Whenever it's a fraction, it is 0. So you start off with 25 factorial 25. That will give you 1. But it's not just 25 factor. 26 factorial will also give you 1.
Right.
26 factorial has a 25. 27 factorial also has a 25.
Yeah.
So you are counting it wrong if you are just saying there are, I don't know what you said earlier. Every factorial above 25 has a 25.
Yeah. Right.
Those will add extra powers of 5, right?
Yes.
If you add up that, then you'll get the correct value. 975s were there, but there are more powers of 5 than you have said. It's not 54. I don't know what you said earlier.
Right.
When the n value is between 26 to 49, there is 11115 extra.
Yeah. Right. Yeah.
When it is between 50 to 75, there are 2 extra 5s.
Yeah.
So you have to count this number properly, what is coming in this.
Yes. So 154.
There
But
are 154 powers of 25, which means there are 154 extra powers of 5.
yeah.
You add that to 970, and therefore you will get a number bigger than 1000, and your remainder will be 124.
Yes.
That is your answer. And to count powers of 5, you have to, powers of any prime number, you have to do this summation, this type of a summation.
Yeah.
You don't have to actually like start counting it. You have to do this summation to figure it out.
Yes.
Okay, we'll continue in the next class with number theory itself. We have to finish this section of the syllabus. So
Okay.
see more number theory problems from your AMCs. If there is any particular thing that is not working, we have to discuss that.
Okay. All right.
Okay, that's all for now then.
Thank you. Bye.
Mm.